MDF files, master database files, it's possible to extend the capacity of a database. Initially, the content will be allocated to master database files, MDFs. Secondary files, NDFs, can be allocated. In addition to hosting the data in database files, we also have transaction log files that are used to record the changes. Okay, and these transaction logs are very important when it comes to recovering a database to a particular point in time. We can then we can establish the content of the database so that we can say restore to a particular point in time. Okay, so yeah, SQL Server components, primary database file, MDS. Within primary database files we'll have tables hosting the data. As changes are committed to the database, the record is maintained within transaction logs. Now the transaction logs are maintained by SQL in a number of ways. So the database can be configured to look after its transaction log using a setting called the recovery model. This is a SQL database setting. The recovery model can be set to one of full, bulk, logged, or simple. If the recovery model for a database is full, then SQL does not truncate the transaction logs. The transaction logs are allowed to grow and grow and grow. We are reliant upon a backup product to come along periodically and truncate the committed transactions. So a committed transaction is a transaction for which the changes have been established within the database file. Does that make sense? Okay, so here's a backup regime. Full database backup, differential database backups. Okay, so let's say I'm doing my fulls on a daily basis. This is Saturday, this is Monday, Tuesday, Wednesday, I've been following Sunday, Monday, Tuesday, Wednesday, Thursday, and so on. So I have the ability, my recovery point objective is 24 hours. If I wanted to make my recovery point objective more granular, on an hourly basis, I could perform T-log backups. Now, if I want to perform T-log backups, I'm going to need those T-logs to be present in order to be able to capture the changes. Okay, so to do T-log backups, the recovery model must be set to full. Okay, when a T-log backup occurs, the committed transactions are removed from the transaction log, relieving the SQL Server of its burden of hosting that information. Does that make sense? Okay. Now, it may very well be that in your environment you only need to do fulls and differentials. You don't need the T-log backups. Under those circumstances, in order to ensure the log doesn't grow too large, then set the recovery model to be simple. Bulk logged. With bulk logged, most transactions are logged and retained. However, some information is lost. Okay, it is not maintained within the transactions. Okay. So, standby databases. In SQL, it's possible to have a primary database server configured through something called log shipping to send its updates to a standby SQL server. So here's our primary, sending through log shipping updates to a standby SQL server. In the event of the primary server failing, the standby SQL server can be brought online and made available to the users. Okay, the users make updates. They make changes to the data contained within the databases. Upon repair of our primary database server, we need to get those updates over to the original location. One method would be to take a backup of our standby server, and then after backup, restore that data to our primary location. As we no longer want this system to be the primary, it was the standby, as we no longer want the users to access this location, we want the users to access this location. After the backup has been completed that we're going to use as a basis for the restore over here, we can get the backup job to automatically put this standby location. This standby location has been brought online, we can put it back into standby mode. Okay. Does that make sense? And then we can get this system back up to date with the changes that have been committed. Okay, so the agent for SQL Server Basics. So the agent provides support for database, transaction log, and differential backups. Automated restore of the system databases. Databases such as the master database can only ever be backed up using fulls. We can only perform log and differential backups of, typically it'll be the application data, user databases. Fully compliant with simplified disaster recovery can be included in those automated restores. Restores of SQL databases to alternate locations, fine. Hot backup copies of databases to the local SQL server. Backups of multiple instances, standby database, database consistency checks. So we have different types of consistency check. We can perform physical. Okay, physical is actually the consistency check that has the least overhead in terms of processing. So it's, yeah, the files look good to me. And then you have logical consistency checks. Logical consistency checks using indexes and so on. So these can become quite thorough and resource intensive. Consistency checks can occur before the backup and after the backup. Okay, before the restore, well, after the restore, to make sure everything's okay. Support for full recovery model, bulk logged recovery model, simple recovery model. So a database can be placed into one of those modes. Okay, so generic agent for SQL Server functionality. In 2005 or later installations, the SQL agent provides support for database snapshots. Now these are interesting in that a snapshot is being created within the SQL server, but it's not actually being sent to the backup exec media server. All we're doing is getting our backup exec media server to say, hey SQL, create a snapshot now, a logical point-in-time view of your content. Backup exec is fully aware of the snapshot and its content and when it took place. However, backup exec doesn't actually host any of the data. Copy backup jobs. A full backup was not actually going to disrupt any existing, so differential database backups and so on. So a full copy backup that will not affect the workflow of a full followed by a series of by a differential and so on. Maintaining replication settings during redirected restores, so yeah, verify only restore jobs. So this is establishing whether or not the content and the metadata are available to perform a restore. So it's like doing a restore to a null device. You're saying, yeah, if you were to go ahead with a restore, it's highly likely that the restore would work. There's no guarantee, it's no substitute for a real restore. Backup with checksum generation. So yeah, here we are validating the content as it's written. Continuation of restore jobs when errors are detected. In SQL Server 2008 Enterprise Edition that supports encryption, you can use SQL software compression for backup jobs to optimize the communication between the client and the media server, the backup exec server. Okay, so requirements for using the SQL agent. So here we have a backup job. It's not a scheduled job, it's a one-time backup job. And we've got the SQL options here. So backup method, full, differential, log, and so on options. As this is a one-time, not in conjunction with a series of other operations, the backup method will be full, back up the entire database. There won't be the option, because it's a one-off, a one-time, it's not used in conjunction with any other operations. You won't have the option for T-log, you won't have the option for differentials. So consistency check before backup, so physical, logical using indexes and so on. What happens if the consistency check is unsuccessful? Do we carry on with the backup? Yes, let's just back it up. Do we want to do a consistency check after the backup to verify that the backup operation has not had a detrimental impact upon the backup or on the SQL instance? Okay, so yeah, checksum validations, create on-disk copies of SQL backups to be placed on the SQL server where the database is located, etc. So do we enable compression for 2008 and later? So backup exec must have access rights to read to, yes. Now these registry keys, if the backup exec service account is a domain admin, it will have local sysadmin rights, so it will by default. It's not something you need to worry about. The backup exec server must have access to the SQL installation. The agent for Windows must be installed on the remote SQL server to be backed up, so yes. The client software for backup exec. The credentials stored in the backup exec logon must have been granted system administrator role on the SQL instance. So within SQL, there are two types of authentication: Windows authentication or SQL Server authentication. If you have set up SQL Server authentication, then you'll need to specify a logon account that has credentials to access the SQL instance. If you're using Windows authentication, then you just the service account will work as long as it's got domain admin is got administrative access. Rob, do you have a?
Yeah, we got away with backup operator.
Did
public.
you?
Yeah, just for backing up. I think that's only if you want to restore.
Yes, of course. Yeah. And so in terms of backups, fine. When you're doing a restore, which is quite likely you probably will need to do, but yeah. So just as long as you're aware that restores until, unless so restores are going to use the same account and they're going to fail if you've got the backup operator at the moment. Okay, so specifying the logon accounts to access the databases. So depending upon the authentication mode, Windows or SQL, choose the appropriate set of credentials. And of course you can validate with a view to performing a backup. Okay, test, edit the credentials. Okay, so supported SQL Server versions: SQL Express Edition 2005 32-bit, SQL Express 2008 32-bit and 64-bit. So I mean, basically, this is just a list of versions. For the up-to-date information, have a look on the support website at the software compatibility lists. So installing the agent for SQL Server, it's bundled with all the others in the agent for applications and databases. That is something that we spoke about yesterday, bundled with Enterprise Vault, Domino, Exchange, SharePoint, and so on. There it is down at the bottom, very easy. So using snapshots with the SQL agent. Okay, so snapshots can be established using the advanced open file option in conjunction with the advanced disk-based backup option. So with 2003 and later, Windows 2003 and later. So the SQL agent supports snapshot technology for SQL through the use of advanced open file option and advanced disk-based backup option. Okay, so this can reduce the restore time and improve backup performance. So when a backup job is submitted that uses the snapshot technology, backup exec momentarily suspends write activity to a volume, snapshot of the volume is created, data is backed up from the snapshots, and the snapshots are then deleted. So these are snapshots being created in conjunction with SQL and backup exec. So that backup exec is storing information that was hosted. Okay, so backup exec hosted in the snapshot. Backup exec is hosting the data here with these snapshots, integrating with the SQL agent. Typically this would be used with 2003 environments, Windows 2003 servers. Snapshot technology considerations. When you are using the snapshots with the advanced open file option, an advanced disk-based backup option, the use checksum on backups and the create on disk copies of SQL backups to be placed on the SQL server where the database is located. Those options are not available when you're using the advanced open file option snapshot method. For 2005 or later database snapshots, here we're instructing the SQL instance to create a snapshot that will be hosted within the SQL server's local resources. Okay, backup exec does not actually store the data. Backup exec maintains in its catalogs a reference to the snapshot and what it contains. Okay, so we could configure this as a scheduled operation. We could configure it as a one-time operation. So here we're doing an example of a one-time backup to disk. Specify the database snapshot. So full, no. Copy, no. Database snapshot. Okay. A read-only point-in-time copy of the database.
Could you point that to an SMB share or a SAN or something like that?
It's not the location that's used is defined within SQL. It's not, you don't specify a destination. SQL will just, in fact, it's just a transient copy that SQL is tracking. So, reverting a 2005 SQL instance database using a snapshot. So here we've had backup exec tell SQL to create a snapshot of its content at a particular point in time that is hosted locally on that SQL server. Okay, so in SQL 2005 or later, database snapshots can be used to revert a SQL 2005 or later database back without having to run a full database restore job. We haven't had to get the data back from the backup exec server because the information is all available to the backup to the SQL host itself. Okay, so the following caveats apply when reverting a database. You cannot undo a 2005 or later database that has been reverted. Okay, it's a bit like a storage checkpoint in a file system. Before reverting a database, backup exec will delete all existing database snapshots except for the snapshot used for the revert. You cannot redirect a database snapshot restore job. It's got to go back to its original location. Well, it is. It's hosted. It's all within the same storage. It's just a representation of the file system of the database contents at a particular point in time. It's an operation that's been tracked within backup exec. Encrypted SQL databases. SQL 2008 R2 supports transparent database encryption. TDE lets you encrypt SQL 2008 databases at the backup set level. Microsoft recommends you back up the certificate keys and encryption keys with the database, of course. Otherwise, it will render the content unusable. Okay, so backing up SQL Server. Let's have a look. Okay, so there are strategies that we can apply according to the size of your environment. If the environment is relatively small, then on a daily basis, you can afford to perform daily full backups. Okay, so daily full back, so on a daily basis, daily fulls. Okay, every day, full database backup, and we could, in order to be able to, yes, so daily full backup, and in order to prevent the transaction log from growing, after doing the daily full, run the daily transaction log backups with log truncate. So to prevent the transaction log from growing and growing and growing. So depending upon the database infrastructure, yesterday we saw a slide where it said that full database backups do not, full database backups do truncate the transaction logs. That can be the case with certain applications, but for SQL, a full database backup will not truncate the entries in the transaction log. We'll need transaction log backups to ensure, if we, whether or not we have these transaction log backups will depend upon the recovery model of the database. If the recovery model of the database is set to simple, SQL will take care of its own transaction logs. They don't need to be cleared down. If, however, the recovery model is set to full, then we have the opportunity to back up the logs and establish a granular point in time. We'd be performing transaction log backups on an hourly basis, typically. Does that make sense? Okay. Mid-sized environments, we could have weekly full database backups with daily transaction log backups to clear down the transaction logs and daily differentials. Getting progressively bigger and bigger. So full backup, T-log backup, truncate. Differential, all the changes to the database since the last full, T-log backup. Differential, all the changes since the last full, T-log backup, so on and so on. Large environments, weekly full database backup, and a transaction log backup, and then daily differentials getting progressively bigger, and we could have hourly T-log backups to provide the greatest level of recovery. Yes, Rob?
Do you, differential backups, do they flush the transaction?
No.
Oh, they don't, that's what I was going to ask, yeah.
So differentials don't either.
Right.
So you'd use T-log backups to maintain. And again, the recovery model is going to have an impact here. If you have the recovery model set to simple, the transaction logs will be truncated upon checkpoints internally controlled within SQL. Okay, there used to be a setting called truncate log on checkpoint, which was many versions ago, which has been superseded with the simple recovery model. So simple recovery model means that you can restore from differential database backups and full backups. If you have the recovery model set to full, the transaction logs are not maintained by SQL. The transactions logs are left in place for backup products to be able to capture.
Is that new in this version? Simple?
No, this has been around.
Oh, simple.
So simple, bulk logged and full, SQL 2000 and later.
Oh, well.
Prior to that, 7.3 and so on, you'd have truncate log on checkpoint. Okay, so SQL backup strategy recommendations. Yes, do protect the entire SQL server with simplified disaster recovery. When you upgrade, run new full database backups. Run consistency checks before the backups. Back up your system databases regularly, master, model, MSDB. Run one backup at a time. Don't have multiple operations processing the same data concurrently. Backup transaction logs on databases configured for the full recovery model. So, where we have, within SQL, databases configured to run in the mode where the recovery model is set to full, do back up the transaction logs. What would happen if you didn't back up the transaction logs and the database was configured to run in full recovery model? It would just grow, 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 and grow. Okay, so database backup methods. Full database backup. Backs up the entire database, including all system tables. System databases can only be backed up with the full model, full method. Okay, so that would be the master database, MSDB, and so on. Differential backup. Backs up only the changes made to the database since the last full backup. So differential databases become progressively larger and larger as time goes by. Smaller and faster than a full database backup. Run log backups between the differential backups in order to maintain, in order to preserve, to prevent your transaction logs from growing and growing. Consider using when relatively small amounts of data changes between the full backups of the same data changes. Full copy only, so 2005 and later. So similar to a full backup, except that it wouldn't impact. It's not going to, if I did a full copy here, it's not going to reset, it's not going to wipe the slate clean, so that this differential is exactly the same differential as would have been performed without that having occurred, that full backup. Does that make sense? Okay, so it's look but don't change. Okay, mirrored SQL database configuration. The SQL agent supports a mirrored SQL database configuration, although Microsoft places limitations on the mirroring of SQL databases. So for redundancy, these limitations include you cannot back up or restore a mirrored SQL database. You cannot restore the primary SQL database whilst it is configured in a mirrored configuration. You can back up a primary SQL database and its transaction logs only if the backup job does not leave the database in a non-recovered state. Is anybody using the mirrored SQL? No. Okay, so backing up the transaction logs. Okay, log truncate, log no truncate. Log truncate will back up only the data contained within the transaction log, and the truncate committed and purge, remove, truncate committed transactions. Truncate transaction logs to prevent them. It will truncate transaction logs to prevent them from growing and growing. Log no truncate, not the norm, only used when perhaps I want to capture where I've got during a restore. So let's say I've got this situation. I've got a full followed by a series of differentials and then a series of T-log backups. Okay, so I'm going to need to restore the full, most recent differential, and then a series of T-log backups. Now, let's say I've got to this point here, and I've done a couple of restores of my T-logs. I do not want, I want to capture what I've restored so far before I do any more T-log restores. So I could perform a backup of what I have restored so far without actually removing the transaction log entries. That's when you would use log no truncate. So backup inaccessible transactions where we have an inconsistent database that hasn't been committed, it hasn't been recovered yet. Uncommitted transactions are rolled back, committed transactions are not removed. We haven't established the state at which the database is to be placed into. Okay, so available in one-time only backup. So this would be a one-off to establish a backup of my transient recovery operation. Consistency checks for SQL. Yeah, SQL reports will report any inconsistency issues, so any consistency check failures in the backup exec job log. Symantec strongly recommends that you always run a consistency check before the backup. Backup exec's consistency check uses these utilities: check DB, check catalog, so check content, check metadata, using indexes, without indexes. So check catalog is effectively using the index. Physical only is ensuring that the files can be accessed. Okay. So let's have a look at the server backup definition. So I can perform a one-time backup. I can perform scheduled backups by clicking on backup, backup to disk. I then get my job definition. And so there's a one-time backup, full only. Scheduled operation, I can specify fulls and incrementals, so on. Okay, so to work with the instances, the databases to be backed up, click on edit here. To work with the mechanism, the method for performing backup, so I could add an additional backup here, so I have a full database. I could have an incremental that is type differential. That's really, you can have an incremental that is type differential. So you can have incremental that's type differential, you can have an incremental that is type transaction log backup as well. Okay, so specifying the item, the database is to be processed, so SQL Server instances, we can then see, so select the instances and the database contained within the instance will be processed. Here we've got the text-based view, include all databases within this server environment. Okay, so there we've got our one-time backup, a one-off operation, full backup of the instances on this system. So the backup exists server SQL instance will be processed. We can add, so we have a full differential, so a differential as an incremental, and we can add an additional transaction log backup as well on an hourly basis. So to add that, click on Edit, and we then have the backup methods. So the backup options provided by that Edit button, go to SQL, and we've got our full backup, we've got our incremental. So incremental method for SQL log backup, you can just about see an L for log. Incremental method for SQL, you can have differential. Okay, so you see how we've got the full pane here, and then we've got the incremental pane here. We can add another, so we've got a full, we've got an incremental that looks like it's probably an L for log there. We can have another incremental that is D for differential. So that would be 3 types of operation. Okay. So, backup method, full, backup the entire database. There we are. So there's our full, so we're working with that particular one. Consistency check before the backup, physical, logical using index. Do we carry on with the backup if the consistency check fails? We want to perform a consistency check after the backup, so on. Okay, now, that's our full at the top here. Incremental, there could be 2 incrementals. So we've got our full and 2 incrementals. On a daily basis, we could have an incremental that is type differential. On an hourly basis, we could have an incremental that is type log. And then to identify the nature of the log, is it log truncate or log no truncate, only to capture your transient restore environments typically, you then specify the type of log backup. But that will become available when you've selected log. But, okay, the rest of those settings are pretty much. Okay, so here we are looking at the options for a one-time backup, a one-off, not scheduled. Okay, notice there is no option for a differential. It's only fulls. You could do a one-off log or a log no truncate, but there is no differential option available here. Okay, does that make sense so far? We're building up those options.
Yeah.
Let's now have a look at restoring a database. Okay, it's possible to restore to a different location. And indeed you'll be doing that in the lab exercise, if I remember correctly. Okay, so within the SQL Server's database settings, so we can define the recovery model. The recovery model is set on a per database basis. Not per instance, it's per database. The recovery model, when set to full, will give the backup exec administrator the ability, should they desire, to restore a database to any point in time using transaction log data that has been captured and maintained by the backup product. Okay, no data is lost, no logs are truncated by SQL. Simple will give the administrator of the backup product the ability to restore a database to the end of any backup, any database backup, full or differential database backup. Okay, so if these are being performed on a daily basis, that's the level of the recovery point. Okay, when a SQL database is running in this mode, SQL is truncating transaction logs before the backup product has had the opportunity to capture the changes. Bulk logged provides the administrator the opportunity to recover the database to the end of any backup, full or differential. Will require databases to be redone, database changes to be redone when transaction logs are damaged. Okay. Bulk logs. Most operations are logged, however there are some operations that are truncated. Revert from snapshot. Revert from snapshot is instructing SQL via backup exec to establish a database to the state it was at a particular point in time that was scheduled by backup exec. However, backup exec is not actively hosting the data. Yes, Oliver?
If you have a revert from snapshot method in place,
Yes.
and you also have in a separate backup job a full recovery backup method in place. So let's say
You're using two different approaches then.
Yeah,
You've got backup exec hosting an instance of the data, and you've got SQL hosting an instance of the data that was created within SQL.
Yeah. Well, the revert from snapshot means it will take place a snapshot on a certain time.
Yes.
It will not do a consistent snapshot.
No.
It will
It'll just
every
be-
hour or whatever it will be.
Yeah, it's
So-
that point in time.
And that will mean that in between data that has not been snapshotted will be lost.
Absolutely.
Yeah.
Yes.
So if you do a revert snapshot, which is the fastest method, I think.
Yes.
Yeah.
Yeah. There's no actual data being transmitted
Yeah.
between the backup exec server and the clients. It's
Yeah.
all on the client already. Yeah.
And if you have a separate backup instance to backup full database backup on a daily basis, and maybe
Yeah.
on every hour or so transaction logs, will you be able to revert from the snapshot and then afterwards revoking the...
You would,
instruction?
yeah. I mean, you could use a combination of the two, in that you could get your SQL instance to a starting point, and then use, so long as you have got backups taken after that snapshot was, you could use a combination of the two, indeed, yes.
But they can't be in one and the same backup instance. It has to be two separate jobs.
Yes, oh yes, yeah. Yeah. Okay, so the recovery methods for SQL, restoring SQL database backups. Okay, restore the database backup, or restore the database to the time of the last backup, whether it be full or differential database. Restoring transaction logs up to a point in time. Okay, so full, this, logs, dotted over that period of time, so we can establish a particular point in time. So it could be using the T-log information that's been captured to establish a state at a point in time. It could be using the T-log information that's been captured to establish a transaction number, okay, a named transaction. So this is where you work in conjunction with your SQL DBA. Restoring the master database, always backed up with fulls. Okay, so you could use this to replace the corrupted or missing tables within the infrastructure database, the master and model database.